Good morning. I'm Jasmine G.
I'm Nichelle'Le Carrington.
And Petronia Marshall.
And we make up the Genius Ones design team. Today we're going to talk to you a little bit about our senior design project. Our project is entitled HOME, standing for Home Outpatient Monitoring Equipment. A little bit about why we chose this project. At-home healthcare can tend to be a little expensive sometimes and time consuming, and it takes a lot from the medical professionals and the patients. So we wanted to design a device that could remotely and wirelessly monitor critical vital sign information that could be critical for certain patients. One objective for our project would be to monitor and record patient vital signs from a convenient low-powered device and be portable and be worn on the patient's body. Well, certain engineering requirements that we would need in order to complete this task would be for our device to sync data to a central controller system. Also, we want our device to send alerts if any critical data is measured. Also, we want our systems to support more than one sensor, so it should support multiple sensors.
Moving on to the design architecture. Pretty much we have a simple block diagram here, kind of showing the data flow. And more specifically, we did a more visual graphic of the actual devices that are used here in design implementation. So within the design implementation, we pretty much used a variety of different hardware and software to kind of complete the entire system setup. So as far as the hardware, we used Wasmo Pro modules from Nichelle'Le. We use Zigbee wireless communication modules, and an Android device, and this can be any Android 3.0 enabled device. The system uses Bluetooth to communicate that data from the wireless system network created with the Wasmo to the central controller, which is the actual Android device. From that point, data is pretty much stored, one in the local database initially, and then secondarily in a more permanent online web-based database.
As a result, we were able to build a low-powered, wearable, easily maintenance and inexpensive remote patient monitoring device that, with further study, we can add different sensors to see which one better affects the patients and tell you more about the patient's health at real time. And also that if in further study to gear the research more towards redefining the system to make it more efficient, real time, and interoperable with different vital signs.
Right now we're going to move on into demonstrating a little bit about what our design can do. So if you want to move closer, you can now.
To a central device test document. It's a black box test. Black box test. So I guess we'll get started. To demonstrate, I have here 2 coordinator modules for our wireless sensor network. They're each programmed with different software to carry out a different test document. So I'll pretty much start off with this one. So let's see data being controlled and captured by the central controller. So once I get everything powered on, now that we're all powered on, we'll get our software started on our Android device. And you pretty much log in, which is our second step. Third step will pretty much validate that we're capturing sensor data. So we'll go ahead and connect to the Wasmo we see here. And then we have our device connected, and you see different readings actually happening. In a couple of seconds. Adjustments. And we're right on the way. And we had a connection. There we go. You see, you should have pulse data, a temperature reading, and humidity reading. The temperature and humidity reading are the temperature and humidity of our environment inside this room, and the pulse is my actual pulse.
So you're getting your heart rate is too high. You're getting like how many times per second?
Right now, it's actually reading every 1.5 seconds. Got a little couple of delays in there. So every 1.5 seconds, it's taking a reading of all the different sensors.
Right. So can you explain a little bit about the sensors that you got on your finger and your hand?
Here, as far as the pulse meter, pretty much designed to either go either on your finger or on your earlobe. So here I have it attached to my finger.
And where's your temperature sensor?
And my temperature sensor and humidity sensor happen to be under my.
Does it actually like touch your body?
No, they're not touching my body. That's just taking the environmental of the environment. So the idea is, like we said before, is just to be able to pretty much have a modular device. So if we want to have a patient with a particular ailment, we can study from that realm, whatever the ailment may be. Kind of having the device specific to the patient.
Okay, so let's say you're getting this data for each, like every 2 seconds. So, like how long is gonna be your battery life for this device, do you think? Like this is like too much data.
Thus far, I've ran the actual watch mode here on my wrist, and a central controller, wireless sensor network, lasts up to, well, as long as I've ran it with these actual programs, it's been about 2 weeks.
2 weeks?
Yeah.
Okay.
But I'm pretty sure with improvements, better programming. And right now, this device isn't even sleeping, so it's just kind of in the highest power consumption mode. So.
Mm-hmm. Yeah. Okay, what kind of other sensors you had planned to add to this device? So you got your own sensors?
Mm-hmm. So we intended to add a scale for weight, just to be able to check the patient's weight. And this will be something that the patient will have to get up and actually go get on. But once your steps on it, everything's pretty much automatic. So you get an indication of you you've been on the scale for the right amount of time, and then it sends it back.
So even if you have like multiple sensor, if you just have one Zigbee transmitter, it's gonna be enough for you. Or you're gonna have multiple transmitter and they like send data separately to this.
So depending on what the sensor may be, so for instance for the weight scale, it'll be a separate transmitter. So pretty much the same thing I have here on my, well, not the exact same setup, because I wouldn't have to attach as many sensors because I have a couple different here. It'll be more here, but for the weight sensor, we'll just have another Wasmo pretty much equipped with the Zigbee module, just to send the data for that particular data read. And for any other things that the patient might have to go and move and have captured. But the idea is to get everything as far as the body, the patient, as far as blood glucose, that kind of thing. Any type of wearable sensors will be just from the node on the patient.
Okay, good. So right now, do you have any alarm set for your program?
No. I tried. Well, pretty much I tried to implement a couple different alarms, and the Wasmo actually comes with a pretty good, software base to kind of help with interruptions and that sort of thing. So you have the capability to check for free fall and if your sensors happen to be out of whack, you get some crazy reading. And like you saw, my heart rate was too high, and that's just because of how the sensors are kind of intertwined. So just kind of finding the right ports and that sort of thing. When it comes down to the kind of refining those type things.
Just one more question. So is your communication two-pass communication? So can you send the command from your cell phone to, for example, shut down one of the sensors?
Currently, that you can't, but that's a viable option. Well, in the long run, a finished system, that would be the actual goal. Even to be able to check where your battery statuses are, if you needed to charge, or if an error went wrong, you could probably just want to restart the whole network, that sort of thing. Okay. So yeah.
Good. Okay.
So this next test case pretty much deals with having a variable rate for the different sensors that are attached. Before, you could pretty much saw like all the sensors data being gathered at the same time. This time you'll pretty much see our pulse being a more important vital signal that is more likely to change faster. So we'll be taking that.
That's a good feature.
So we'll be pretty much taking that at a faster rate than the temperature and humidity. So connect again. Alright, so here we go. So I just did a simple, as far as the data rate, it's really simple. Let me get.
Hi, I'm Bobby White, and I want to come to you today to tell you about the lessons we learned as a group and how we work together. Throughout this entire project, we encountered some problems. Each problem that we faced allowed us to work together as a group to come up with the best solution. There was an issue with our parts arriving here late. The delay in the parts caused our group to have a short amount of time to get all the functions working on the device. By this problem occurring, it showed that we have to do a better job at planning for things like this to happen. If any of us plan to continue work on this project, we can implement various other sensors that can be attached or interchanged onto this device. Also, we can make the device sync in real time to make it more accurate measurements. This research and design was essentially a proof of concept, and any future research should be geared toward refining the system's processing capabilities and low power energy consumptions.